Hi, everybody. It's Professor Mitchell, continuing with Chapter 4. Today, we're looking at Section 4.3, Solving Systems of Linear Equations by Addition. So you'll recall that in the last two sections, we've covered two other methods for solving systems of linear equations. First, we covered graphing, and then we covered substitution. So this is the third method. The addition method is also known as elimination by other textbooks. So this is the only objective that we will cover in this section. And as in previous sections, it goes along with SLOB, solve linear systems. All right, so the addition method is based on the addition property of equality. And the idea is that if you have one equation that says A equals B, one expression equals another expression, and you also have C equals D, then you can add C to the left side and D to the right side because C and D are equal. So my first example is going to be to solve this system of equations by addition. 4x plus y equals 13 and 2x minus y equals 5. So I'm going to go over to the tablet, and we'll stay on the tablet because I just have a bunch of examples of solving by addition. Now this one happens to be very easy because notice that in the first equation you have a plus y, and in the second equation you have a minus y. That's not going to happen very often, so I'm going to appreciate it when it does. Since those two terms are opposite, what I can do is just add the left sides of these equations together. 4x plus 2x is 6x. Y plus minus y cancels. That's why I'm so happy about this situation. And then on the right hand side, 13 plus 5 equals 18. So adding those two equations together gives you 6x equals 18, which of course means x equals 3. All right, so now remember, for a system of equations, we need an x and a y. So now just substitute that value of x into either one of the original equations. I'll pick the first one. Sub into first equation. You can pick either one, it doesn't matter. All right, so we have 4x plus y equals 13. We think x is 3. So that gives us 12 plus 1 equals 13, which means y equals 1. All right. So it looks like the solution is 3, 1. I will definitely check this one. And then for the rest of the section, I probably won't do the check. I'll just remind you to do it as often as I remember to remind you. All right. Remember to check it in both equations, starting with 4x plus y equals 13. So we'll write that as 4 blank plus blank equals 13. We think x is 3 and y is 1. 4 times 3 is 12. 12 plus 1 is 13. Okay, and then the other equation was 2x minus y equals 5. So we'll write 2 blank minus blank equals 5. And when I put in 3 for x and 1 for y, 2 times 3 is 6. 6 minus 1 is 5. Woohoo! All right, so the solution really is 3, 1. All right, let's look at the next example. X plus 4y equals 14. 5x plus 3y equals 2. So unfortunately, if I just add these two equations together, that's not going to help. It's just going to give me 6x plus 7y equals 16. So what I need to do, and this is usually the situation, is multiply one of the equations by a number that will give you a pair of opposite coefficients. So in this case, what I'm going to do is multiply the first equation by -5. And when I rewrite the new first equation, I think you'll see why I did that. So -5 on this side, -5 on this side. Be sure to do it on both sides. -5 times x is -5x. -5 times 4y is -20y. 14 times -5 is -70. And I'm going to keep the original second equation. Okay. So the reason that I multiplied the first equation by -5 is that I saw that it would create the opposite coefficients with the x's. When I add these left-hand sides together, the x terms will drop out. -5x plus 5x cancels. -20y plus 3y is -17y. And -70 plus 2 is -68. So dividing both sides by -17, I get y equals 4. So now I just need an x. And once again, I will put that value into the first equation. But the second equation will work too. All right, so x plus 4 blank equals 14. Y is 4. So we get x plus 16 equals 14. Subtracting 16 from both sides, we get x equals -2. So I think the solution is -2, 4. And strongly recommended that you check that. All right, next example. So in the next example, I'm going to ask you to think about what number should you multiply on one of these equations to get opposite coefficients. We have 6x minus 5y equals 25. 4x plus 15y equals 13. So we don't have any opposite coefficients right now. But if you multiply one of these equations by a number, you will get opposite coefficients. So can you decide which equation and what number? Well, the easiest thing to do is definitely to multiply the first equation by 3. Because multiplying this term by 3 will give you a -15y. Okay, but of course you can't just do it to that one term. You have to do it to every term. So our new first equation will be 18x minus 15y equals 75. I'm leaving the second equation alone. It is 4x plus 15y equals 13. All right, 18x plus 4x is 22x. Minus 15y plus 15y cancels. That was the whole point. 75 plus 13 is 88. So now we'll divide both sides by 22. That'll give me x equals 4. So now I need the y. This time I'll use the second equation. Why not? Sub into second equation. All right, so x is 4. So I'm going to go 4 blank plus 15y equals 13. X is 4. 4 times 4 is 16. And now I'll subtract 16 from both sides. I get 15y equals -3. Divide both sides by 15. You get y equals -3/15, which simplifies to -1/5. So it looks like the solution is 4, -1/5. Again, I would encourage you to check that. Most of these example problems and many of the homework problems are rigged so that the coordinates come out to be integers, but they don't always come out to be integers. Okay, I'm pretty sure this one is correct. All right, next example. All right, this one's a bit of a challenge. We have 6x minus 5y equals 7 and 4x minus 6y equals 7. So when you start thinking about multiplying one of these equations by a number to get opposite coefficients, you get a little stuck, don't you? Because 6 is not a multiple of 4. 6 is also not a multiple of 5. So actually, the only way that you're going to get away with multiplying only one of these equations by a number and getting opposite coefficients is if that number is a fraction. And I don't think we want to go there. So in this situation, we have to multiply both equations by a number. And those two numbers don't have to be the same. In fact, they won't be the same. So one option is to multiply the first equation by 2. And that'll give us a 12x. So that means we want to change the 4x in the second equation into a -12x. And I will do that by multiplying by -3. So this right here is the most challenging part of solving systems of equations by addition, is just coming up with those numbers that will work. Okay, so our new first equation is going to be 12x minus 10y equals 14. And the new second equation will be -12x plus 18y equals -21. So now I'm going to add these equations together. The x's will drop out. That was the whole point. -10y plus 18y is 8y. 14 plus -21 is -7. Dividing both sides by 8, you get y is -7/8. So that's kind of unfortunate. All right, but it happens. So now we have to substitute that value into one of the original equations. To figure out x, I will pick the second equation, and I think I'll do this on the next page. So 4x minus 6y equals 7. And we think y is -7/8. All right. Okay, let's think about this. So first thing I'm going to do is multiply -6 times -7/8. Let's sneak a 1 under here. 6 and 8 have a common factor 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So now multiplying those fractions together, you get plus 21/4, right? 3 times 7 is 21. 1 times 4 is 4. Okay, let's see. What should we do next? You know what? Let's just multiply this whole equation now by 4, and that will clear out the remaining fractions. Okay, so 4 times 4x is 16x. 4 times 21/4 is just 21. I was trying to get rid of that fraction. And 7 times 4 is 28. So now I'll subtract 21 from both sides. That gives me 16x equals 7. Divide both sides by 16. I get x is 7/16. So it looks like the solution to this system is x is 7/16. Y is -7/8. All right. You know what? I am going to show you. You might think, okay, well, forget it. I'm not checking that. I have to plug the fractions in. Well, yes, that would be the best way to do it, but I'm going to show you a shortcut. Okay, and it's not really so much a shortcut. It's just using the calculator to do the check. All right, we don't have to do all this on paper. Okay, so let's see. The first equation was 6x minus 5y equals 7. And we think that x is 7/16. And we think y is -7/8. So if that is the correct solution, then when I hit enter, it's going to tell me this is equal to 7. And it is. All right, so now I'll do the same thing with the second equation. The second equation is 4x minus 6y equals 7. So we're hoping that 4 times 7/16 minus 6 times -7/8 is also equal to 7. And it is. Woohoo! All right, so don't be afraid to use your calculator to do the check, especially when the solution is a fraction. All right, next example, we have x over 2 plus y over 4 equals 1, and negative x over 4 minus y over 8 equals 1. So whenever one or both of the equations have fractions in them, I definitely recommend multiplying both sides of each equation by its LCD in order to get rid of those fractions. So before I even think about knocking out the x's or knocking out the y's, I am going to multiply both sides of the first equation by 4. And I'm going to multiply both sides of the second equation by 8. All right, so I'm going to take my time here. First equation, we're going to have 4, everything multiplied by 4. So let's do this. We have 4 times x over 2 plus 4 times y over 4 equals 4 times 1. 2 into 4 goes 2. 4 and 4 cancel. So the new first equation is 2x plus y equals 4. All right, and then I'm going to do this equation on over here. Everything multiplied by 8. So we have 8 times negative x over 4 minus 8 times y over 8 equals 8 times 1. 4 into 8 goes 2, so that's going to be a negative 2x. 8 and 8 cancels, so that's going to be a minus y, and that equals 8. So that's the new second equation. And when I put it underneath the new first equation, you might be able to see where this is going. This situation did not come up in the last section. 2x plus negative 2x cancels. And remember, I wasn't trying to get the x's or the y's to cancel. That was just kind of a lucky coincidence. Y plus negative y also cancels, which leaves me 0. Remember, once an equation, always an equation. 4 plus 8 equals 12. All right. Well, the last time I checked, 0 does not equal 12. This is a liar, liar, pants on fire. All right, so since those two equations being true at the same time leads you to 0 equals 12, that means that this system of equations has no solution. If you were to graph these two linear equations, they would be parallel lines. All right, and the last example has some decimals in it. Negative 2.5x minus 6.5y equals 47. And 0.5x minus 4.5y equals 37. So I'm going to show you a trick that I haven't used before. This is technically optional, but you might find it helpful. And that is to get rid of all these decimals. Since all of these decimals have one digit after the decimal place, we can clear them out by multiplying by 10. And that's on both of these. All right, so the new first equation will be negative 25x minus 65y equals 470. And the new second equation will be 5x minus 45y equals 370. All right, so now look at these new equations and think about, is there a number that you could multiply onto one of these equations to make either the x's or the y's drop out? And the simplest thing to do is to multiply the second equation by 5, because that will turn that 5x into a 25x. These numbers are getting kind of big, so keep your calculator handy. We're going to keep the first equation the way it is, negative 25x minus 65y equals 470. But the new second equation will be 25x, and then let's see, 45 times 5, is that 225? I don't want to make a mistake, so I'm going to double check. Yes. So that'll be minus 225y. And then 370 times 5 is 1,850. All right, so now when I add these two together, the x's will drop out. That was the whole point. Negative 65y plus negative 225y is negative 290y. And 1850 plus 470 is 2,320. So if we divide both sides by negative 290, we get y equals negative 8. All right. So now substituting that into one of the original equations, I'll go with the second one, which is 0.5x minus 4.5y equals 37. Double check to make sure I remembered that correctly. And we think y is negative 8. So we have 0.5x minus 4.5 times negative 8 equals 37. Negative 4.5 times negative 8 is positive 36. All right, so subtract 36 from both sides. That gives us 0.5x equals 1. And then divide both sides by 0.5. 1 divided by 0.5 is 2. So it looks like the solution is x equals 2, y equals negative 8. And one last time, I'll remind you that it is a good idea to check that. All right, we have one section left in chapter 4. We're going to skip section 4.4 and go right to 4.5. So until then, have a great day, and we'll see you next time.